All right, page 10. So in the previous graph on the bottom of page 9, you were given the slope field and you actually had the graphs. Now you actually have to sketch the graph. So what we need to look at is the trend as to what's happening with our graph. So I'm going to use the highlighter so that you can see each one. Okay, and for A, I'll use this one. So we want to go through 0, 0. So we're looking at going through this point, and you're looking at what is happening to those points or these slope fields. So you need to follow the trend and just do your best. Here, it's not 100% accurate, but it's going to be pretty accurate because you're looking, here I am at 0, 0 before, or excuse me, after. The graph is kind of going like this. And you notice here, because these slopes are 0, this is definitely going to approach that. And then you're coming down like this. So you're just following the slope fields. So see, I'm following these slope fields right here. Okay, and you could probably extend this like that. This is a little bit challenging. So, all right, 0, 1. So what we're looking at for 0, 1 is when x is 0 and y is 1. 0, 1. 0, 1. Make sure you look at the scale too. So this is half because this is totally scaled. And this is nice and easy. Check this out. 0, 1. Follow before and after. Oh, look at that. Nice horizontal line. Okay. 0, negative 1. Okay. 0, negative 1. Let's see. 0, negative 1 is right here. So here I am. Okay, I'm going to follow before. So they're going down in this direction like this. And after. So it's following the same trend as that pink graph. It's going to approach the blue. And because this is too thick for me to draw through, I'm just going to leave it like that. And then 0, 2 will do an orange. 0, 2. That's here. Okay, so here's 0, 2. Let's look at before. So we're up here. Looks like it's going in this direction. And then coming down here like this and approaching the blue. Okay, so these were kind of clear. It does take a little bit of practice, but go to the point, and again, make sure you're looking at the scale. It's really important. Okay, in this last part, I'm going to show you how you would do a matching of a slope field, and you'll actually do that on the next page, and then the answers will be posted on Blackboard. So let's go through some of these key points. If we want to match the slope field, okay, to the following, let's take a look at some of these guidelines. So if the slopes are the same vertically, then your differential equation will only have x's. Okay, if the slopes are the same vertically, so that's one thing that you would want to look at. If the slopes are the same horizontally, okay, then your differential equation will only have y's. So sometimes when you're doing a matching problem, you really want to look at that first and kind of see what the deal is so that you can eliminate those choices first, and it'll make your life a lot easier. All right, if the slopes have a combination of horizontal and vertical, then the differential equation is going to have both x's and y's. So if you have that specific scenario in number 3, you're going to choose a particular point and substitute into the differential equation to find the slope. Okay? And then you would find the point on the graph and choose that one that matches it. Okay? So I'm going to go through these 4 and just kind of talk about which one's going to be which. So first of all, I'm going to look at these and see if I have horizontal and vertical slopes that are the same. So, excuse me, if I go vertically, okay, I'm looking to see if I have the same x's. When I look vertical here, these are not the same slope. Okay? If I look horizontal, these are not the same slope. So this is going to have both x and y in the differential. Okay, and I'm just marking it. So if I go vertically, look here vertically, same slope, same slope, same slope, same slope, same. Okay, so this is probably going to be just x, because it's the same vertical slope. Okay, let's look vertical slope. Down here, vertical slope. It looks like it's the same, but then when you get to the bottom, it's not. Same? No. So let's look horizontally. Definitely not. So this is going to be both x and y. So I'm going to move to the last one. Vertical slopes, definitely not the same, but if you look, horizontal, same, horizontal, the same, horizontal, horizontal. Okay, so this is going to be in terms of y's. Okay, so if I take a look here, it appears as though, let's look at this one. Choose the easiest. In this case, when I'm looking at this, it looks like I have a slope here of 0, if you look here. Okay, and if I look at this scale, it appears as though the scale must be 1, because here, if this is 0, -1, this is at -2. So when x is equal to -2, I'm going to look for my equation that only has x. Okay, and I'm actually going to evaluate this when x is equal to -2. Now in this case I only have 4, so you can use process of elimination, but a lot of times you're not going to be given just 4. So you need to go through and sort of check these out. So when I plug in, I have 1/2 times -2 plus 1. This is -1 plus 1, so that means I have a slope of 0. So that means that this is going to be b. So I'm done with this one. Okay, so now dealing with only y's, I'm going to take a look here. It appears as though this is where I have a slope of 0. Okay, so again, I can pick my value. So, I don't know, pick where y is 0. So when I go up here, I'm going to evaluate when y is equal to 0. So the slope is 0. So this is d. Okay, so that one's done. So here we have these two graphs, and I need to figure out which equation goes with which. So what you want to do is choose a point that is distinguishable between the two. Meaning, if I look here in this one at the point 1, 1, okay, I have a slope of 0, and then 1, 1, I don't have a slope of 0. So I mean, you could choose so many different points, it doesn't really matter. So I'm actually going to choose the point 1, 1 and 1, 1. Okay, so let me highlight this. 1, 1, I have a slope of 0, and 1, 1, I have a negative slope. Okay, so here, slope is equal to 0, m is equal to, it appears -1, but it's negative. I don't know. It could be -1. So I'm just going to pick, and I'm going to evaluate when x and y are 1. Now, it could be any point. You could have picked any other point. It doesn't matter. You just pick one that is distinguishable between the two, okay, or amongst the 3 or however many graphs you have to distinguish. So when I plug in 1, 1 minus 1, I get a slope of 0. So in this case, this one is going to be c. Okay, so I just want to verify that this is a, and to show you, had I plugged into this first, evaluate when we have 1, 1. So when I plug in 1, this becomes -1. So actually this was a slope of -1. Remember I speculated that this looks like it could be -1. So that means this is A. And that is the best way for you to do that.